Okay, welcome everybody to the Earthen podcast. Today, my guest is Aircrete Harry. Welcome, Harry.
Thank you, Scott. Good to be here.
Yeah, this is great. We've had a series of very fascinating conversations, and we've come up with a lot of very interesting ideas so far. So I'm excited to get into it again today.
Yeah, me too.
So I guess we should start off and just tell the audience a little bit about yourself and your background, how you got into construction in the first place, and specifically how you got into this Aircrete stuff.
Yeah, absolutely. So I'm Harry, also known as Aircrete Harry on YouTube. And I got into Aircrete about 2014, or I'm sorry, 2016 it was. And 2016, I was looking to build my own home. So my wife and I, we'd been looking around to purchase a home because at that time I lived in New York City. So we did a 60-mile radius from my job location, 60-mile radius out, and we were looking for properties, looking for homes. Everything was really expensive, and even 60 miles was too far of a drive, especially if you had winter or snow conditions to get to work. It could be like a 2-hour drive easy. So that's 2 hours each way. So the purchasing a house wasn't happening. So then I looked at buying land, and there was a lot more reasonable vacant land much closer to New York City than it was with a home on it. So now the next question was, what type of home was I going to build? So at that time, I was doing some research, and I found this company called Green Rhino Building Systems. And Green Rhino Building Systems, they're located in Arizona. So I did a 3-day workshop with them. And basically, they teach you how to build using styrofoam blocks, EPS foam. So they had these long, 16-foot long, 4-foot tall, and 8-inch thick foam blocks. And so we built a small little 200 square foot cabin. I mean, like within 2 days. It was amazing how fast you could build with the foam. It's so lightweight, you could literally do it by yourself, but we had a group of people. So we just foam glued the joints, put the pieces on top of one another, and we had these big wall sections done in no time. And then it was about skim coating it. So we put a fiberglass mesh up and a latex cement, a thin latex cement coating, which added tons of strength. It gave it some fireproof rating. And the inside of the place was really easy to plumb and wire up because you took a hot wire knife, and you would cut your channels out, stick your plumbing in or your wiring, and then you'd foam glue the piece back on. So it was really fun, fast, and inexpensive way to build. And I was really gung-ho about building that structure when I came back from Arizona. And then I found out about Aircrete, right? I saw Don Gaia's commercial for the Green Dragon machine, which
Right.
was a continuous Aircrete mixing machine. So I saw that, and one of the things about the Green Rhino building system that got to me was when I hit the walls, it sounded like a drum. Like I get it had all the strength. We were standing on a roof. I saw how strong it was, but I just couldn't get over that hollow drum sound whenever I banged the walls. And that bugged me. And I came from a background where I lived in cinder block and poured concrete homes my entire life. I never lived in a traditional stick frame home with sheetrock and things like that. So all my walls were concrete. You hit them, you'd break your hand. It was solid. So
Right.
that's what I was used to, and that's what I wanted. So when I saw this Aircrete, I see these big giant blocks that are lightweight. I'm like, oh, I like this. So immediately I ordered the Green Dragon machine and started making my own Aircrete using that machine. And that's how my YouTube channel started. It was all me doing experiments, figuring out how to make Aircrete. Long story short, the Green Dragon machine did not work as advertised. it was a beautiful concept, and I get the excitedness to produce that product and deliver it to the people. But I got tons of text messages, and you can see on my YouTube videos, the early ones, of people thanking me that I saved them so much money from buying the machine that wasn't going to work for them. And so even though they stopped making that machine and just started selling just the foam generators. But that's how it started for me. I was making Aircrete blocks. They were all weak. They were very easy to crack. And I was just trying to figure out, how do I make this stronger? So I spent 3 years doing experiments with Aircrete and developing a system that I was going to use to build a dome. So I ended up using a combination of technology from monolithic domes, which is their airform technology. So I purchased an airform from monolithic domes to do an experimental build, a proof of concept. So I got an 8-foot diameter dome, 8-foot diameter, 8 foot tall. And I sprayed that with a stucco cement mix. And then I had another airform that I put over the first dome that I built, leaving a cavity. And then my idea and concept was to fill that cavity. And the reason I got to that point is because after 3 years of experimenting with Aircrete, I realized it had no strength, and I was not going to build a dome made of purely Aircrete that I was going to move myself and family into. I was like, that's not happening. It's just too weak. I had a 12-inch thick block that I was able to crack against my chest. Like, it was nothing. So that led me to realize, for me, Aircrete was only going to be used as an insulative coating, as an insulative layer. So that's what I developed. I built a dome hard shell, which is reinforced stucco cement. So you have a 4,000 or 5,000 PSI dome shell. And then by putting the second airform over, I use it as a mold to contain and hold the Aircrete. So I filled that cavity between the airform and that first stucco shell dome I built. And sure enough, that worked. I didn't do a full pour because what I was building was temporary. I didn't have a building permit in New York City. So I knew I had to knock this down eventually. So I built the shells very thin, and it was just a proof of concept. And once I saw that worked, I was off to the races. Then I bought, the large airforms for making my dome, 20-foot and 30-foot airforms, size airforms. And yeah, that was it. I was all gung ho. And then by that time, my wife and I already purchased a piece of land in Colorado. And we were just planning on moving to Colorado. I was doing an early retirement, and I was going to move out to Colorado with my wife and on the vacant land and build our dome home. So that's what we ended up doing.
That is great. Yeah. And I love your story every time. And, I don't know if the people know watching, but it's in my mind, I've looked around, I've talked to a lot of people. You are one of the leading, experimenters, inventors in the Aircrete and even the concrete form construction using the airforms. You have this amazing website and an amazing YouTube channel that a lot of people get a lot of value from. So I just want everyone to be aware. You're selling these airforms that help people create the dome shape very easily. It's like a Tyvek type material. You blow it up with low pressure, right? And then you put the cement over it like a shotcrete. Is that correct?
Yeah. So what led me to that was the airforms that I purchased that are commercial. They are extremely heavy. And so I knew moving out to Colorado, I wasn't going to have any help other than my wife. And then,
Right.
she's going to be limited to what she could lift. So I couldn't even use these airforms because they were hundreds of pounds. And I'm by myself, and you need at least 3 people to just mount it. So walking through Lowe's one day, I walked past Tyvek house wrap roll. So I look at the material and immediately think, man, I think I can make an airform from this. And I had a buddy of mine, Dan, who built his own airforms before and built his own monolithic dome. And a monolithic dome is where you inflate an airform, you spray the inside of the airform with insulative spray foam, and that makes that form rigid. And then you put your rebar hangers into the styrofoam, into the spray foam, and you hang your rebar, and then you spray cement on it from the inside. You shotcrete. So everything is built from the inside. So my buddy Dan had built like 6 domes like this using this method. And he told me that method was very expensive because of the spray foam. He said the spray foam was half the cost of the house. So if it's $100,000 house, it was $50,000 just for spray foam. And so he got in touch with me because he thought my idea using Aircrete was the bomb diggity, and I agreed. But anyway, so I got this Tyvek house wrap. My buddy teaches me how to make an airform, and I make this airform myself on a little Singer sewing machine, a little $120 sewing machine.
Yeah.
I only have very little sewing experience from public school where we had a home ec, and I learned how to use a sewing machine. So
right, me too. Way to go. That's useful
yeah,
skills, man.
yeah, it really is. And so I sewed up my first airform. I mounted it on an epic slab that I built, and an epic slab is just expanded polystyrene with paper infused with cement. So you and water, and you mix those ingredients up, and you get a very strong insulative cement mix. Yeah, cement mix. So I was also experimenting with this mix at the time. And what happened was we're living in an RV. We just moved here in 2019 to Colorado. We're living in the RV, first time, and I'm coming from New York City, lived the city my whole life. So now, for the first time ever, I'm living in an RV. And it was great when we moved here in April, but came November, it started getting really cold, and the propane heater in the RV conked out. So now we had no heater. The RV gets very cold quickly. So I quickly built a dome with an experimental cement mix. So I used the first airform I ever made using Tyvek. I mounted it and was able to spray it with this epic mix, 3 inches thick only, with hardly any reinforcing. So it's a really strong mix. And we've been living in this thing like 4 years now because I haven't built the large home we're gonna move into. So yeah, we use the Tyvek and the whole technique on how to cut your gore shape to make an airform. We have all of that available on aircreteharry.com. There's a whole tutorial. You could buy the online workshop that teaches you everything from making the airform to foundation to spraying to doorways, windows. We have the whole course online now where anyone can build it themselves, because I do get people wanting me to build the airforms for them, but to save them money, I tell them it's less expensive if you buy the course and learn how to make your own airform. You'll be saving hundreds of dollars, and you have a skill that you can take with you. So I really push people to learning to build it themselves opposed to me building it for them. But otherwise, yeah, the airform Tyvek is very lightweight, and all you need is one person to do everything. And that's basically what I've been developing, is how to build these dome homes by myself, you know, without hurting myself, without needing any real heavy equipment. And that's what I was able to get all figured out. And now I offer that to people online.
Mm-hmm. Yeah, that's awesome. You know, it's definitely needed. A lot of people want to get something done really fast, and it's also affordable. And it's just good to put it out there for folks, as you know, you and I do similar things. It's like we're just consulting with people, helping them achieve their dreams, not necessarily building it for them, because we can reach more people that way. There's a lot of people trying to create something, create a dream for themselves. So I think this is a piece in that puzzle. And as you know, my audience is we're really focused on natural materials, and I've been kind of expounding on some of the negative aspects of Portland cement in particular for many, many years, for decades. But there's this little niche appropriate use of these materials. And I think that's where you're at, is kind of the minimum amount of Portland cement for the maximum effect. And the effect is wonderful. I mean, especially I'm looking at using some Aircrete insulation even in some of my projects, because I mean, it really doesn't take very much cement powder to make Aircrete. Is that right?
Yeah, it's true. I've gotten to a 75-gallon mix. So basically what that means is with one 92-pound bag of Portland cement, I can add about 70 gallons of foam to it to really expand it. You're getting a lot of Aircrete from one bag of cement that's very high insulative properties because there's so much air bubbles in it, opposed to the denser mix that's made for building domes, you know, the dome Gaia method.
Right.
That's like a 40 or 50-gallon mix. I got
Okay.
up to a 70-gallon mix because again, my only purpose in using Aircrete is as an insulative material for my structures. So my slab, so I'll build a concrete ring beam, but then the interior slab is Aircrete for my insulation. And also for my walls, when I build a double shell dome, I'll fill the inside with a lightweight mix for insulation. But I have to tell you, I'm a huge fan of the natural materials for building. Like for me, the rammed earth um, is the most beautiful. When you have all those little layers in the walls, you know, when you're ramming the walls with just the soil, and you see
Mm,
all those layers, like it doesn't get more beautiful to me. And earth ships, I'm also a fan of. And when you look at earth ships, they also are using styrofoam for their insulation. Now, that styrofoam they use could be replaced with Aircrete. So if you're really trying to save money, because those styrofoam sheets are getting very expensive nowadays,
right.
and you could pretty much do the equivalent with Aircrete for a lot less money. And but what I focus on and what I tell people is knowing how much energy goes into building, especially natural earth structure, whether it's adobe bag or rammed earth or earth ship. You know, it's a lot of labor that's involved. And if you don't have a group of people to help you with that labor, it's going to take you a long time. I know people who've taken 2 to 3 years to build their earth ships, you know, just pounding tires because you can only do like 3 or 4 tires a day. You know, I've never pounded tires, so I don't know exactly, but I'm pretty sure that's correct.
Neither have I, actually.
Yeah.
Yeah.
So what I recommend to people is if you're doing what I've done and you're going out to a vacant land to build your dream home, and you know it's you're using natural materials, you're going to do an adobe or whatever you're going to do. I really recommend building a cement dome only because of the speed at which you could build something that'll be very strong, very fireproof, earthquake proof, and can be done in a week. It only took me 1 week to build this 16-foot diameter dome that we've been living in for 4 years. Now, yeah, we use the RV that we have for the bathroom and kitchen and stuff. So it's basically just our, you know, master bedroom, the dome. And I recommend it because you could build fast, you can store your equipment or whatever you have in there and lock it and feel secure while you know, if you're like me, you got to drive almost 2 hours to a Home Depot. So when we leave, you know, we lock everything up because you never know. You know, we still live, fortunately, in a country where people like to rob and steal. But you know, that's what I think is the best because if it's going to take you 2 to 3 years, you want to be able to live comfortable. And I'm in Colorado. It's snowing up a storm right now outside. I probably have a good 8 inches of snow right now, and we're nice and toasty inside that dome. You know, it took me 1 week to build it. We're nice and toasty while I've been working on the larger dome home project that we're going to move into next year.
Yeah, it's a great segue into just moving on to the land. You got to have something to start out with, and with an extreme climate like Colorado, it better be warm. That's for sure.
Yeah.
So, yeah,
Yeah,
I'm,
for
I'm
sure.
super curious. I mean, I haven't asked you all the technical aspects of the Aircrete itself yet, but I mean, I gather it's cheaper than your polystyrene or your polyiso or your rigid foam. You know, all these foams you can buy, they're not that cheap at this point, and sometimes even hard to get. There's like materials availability issues. So somebody who can figure out the Aircrete mix, they can buy this, recipe or mixing machine from you, and then they can figure out how to make their own Aircrete. I mean, you're looking at pretty substantial savings. And then it's a waterproof, mold proof, rodent proof type insulation that can go underground, right?
Yeah, that's exactly right. And so, as an example for cost, the dome we're living in right now costs under $2,000 to build. Now, that was because we used recycled materials such as EPS styrofoam. My wife and I, we collected styrofoam for weeks before we built this dome, and we shredded our own styrofoam and paper. So the first dome we built wasn't Aircrete. That was the Epic dome. And we built that dome because it was easier and faster to build using the Epic. Now, when you make Aircrete, you're making a cement slurry. So you use, for example, 5 gallons of water, 192-pound bag of cement, Portland cement. You mix that up and you have basically like a 6 or 7 gallon cement slurry. So you have your slurry that you're adding a shaving cream foam to. This is what makes Aircrete. This has been around for decades. It's in the industry. It's called cellular cement, right? And there's different PSIs you can get. So the less shaving cream foam you add to your cement slurry, the stronger it will be. The more foam you add, the weaker it'll be, but more insulated. So there's a balance. So you could technically build everything of Aircrete of different densities. Depends on what you're doing and what method you're using. So, but the Aircrete has to be put in a form. So that's why usually bricks are made. So you have all these forms that you'll take this liquidy Aircrete mix, you pour it into your forms, and usually like 24 hours, you could take them out and start using them to build, mortar and brick system. But that takes time because you got to have a lot of molds because you're going to need, maybe 2,000 bricks. So it'll take you time to do this. So I learned about this Epic cement mix and decided I was going to experiment with this Epic stuff because it was stronger than Aircrete. I've seen videos of this stuff being hit with a sledgehammer and it would just dent, it wouldn't even crack. And then sure enough, I mixed my own and I have a video of me wailing away with a sledgehammer and the stuff doesn't crack. And I'm like, wow, this is, in my mind, I'm like, this is what I want to build my house with. Not Aircrete, where one whack of the sledgehammer will shatter it into pieces.
Right.
So that's why I ended up doing it. So we ended up getting the styrofoam beads. We recycled. We would go to rent-a centers. That was where they have a ton of styrofoam because they rent furniture out. So they get furniture and appliances brand new, and it comes with a ton of styrofoam. So you could go to rent-a centers. That was a great resource for styrofoam. They're more than happy to let you take it away. So they're not filling their dumpsters up with styrofoam because it's very bulky. So we would collect the styrofoam, we would shred it, and then we would mix it into the cement mix and the ratios that they needed to be mixed. And we would spray it on it and it worked great. And so that was that. But what I did last year was I made a double shell Aircrete dome. And what that means is you don't need any styrofoam and you don't need paper. All you need is cement and your Aircrete Harry foam generator. And so now, cement and sand. So now the idea is And this is for people who don't want to bother dealing with styrofoam and shredding it and paper, and it
Okay.
becomes easier. So
Right.
you just mix up your stucco mix, you spray your airform, so you have a reinforced cement dome, right? Because you'll put a fiberglass mesh and you'll spray all that, and it'll be a very thin shell. You'll be anywhere from 2 inches to 1 inch thick. And that's a very strong shell, reinforced. And I didn't mention this, but this is the other reason why you could legally build this structure in the United States, is because that very first dome is a reinforced stucco cement dome. And all the engineers, you tell them, you're doing a 3-to-1 mix or 4-to-1 mix, which just means for 1 bag of cement, you would add 4 bags of sand, the equivalent weight. So if
Sure.
it's 92-pound bag of sand, cement, then the sand comes at 50 and 100 pounds. So you'd add 4-to-1. And so you'd get a 4,000 or 5,000 PSI mix. So the engineers know this. So when you explain you're building this hard shell that's reinforced with rebar, stucco wire mesh, whatever, then you have a shell that they can understand, okay, that'll be safe. Now, what you have to explain to them is aircrete and how it's, because they don't know. And you have to explain it's a lightweight insulative cement. It has X amount of R value. So the system
So
I
what is
developed
the R
was,
value? Do you know?
the R value numbers that are out there vary between 2 per inch, R2 per inch to 4 per inch. So
Okay.
it really depends on the mix. And next
Okay.
year, I'll be sending samples out to be tested by a licensed R value engineer. So we'll know exactly what it is, because as I mentioned, you could get different densities of aircrete. So obviously you're gonna have different R values.
Of course.
So like the 70-gallon mix that I made is gonna have the maximum R value. And that could be up to R10 per inch, but we won't know until it's actually tested. So the double shell dome is very simple and really inexpensive to build. You could get 1 pallet of cement, Portland cement, and that comes 35 bags of cement on a pallet. And you could build what I built, an 11-foot diameter dome for 1 pallet of cement. So we're talking about the concrete ring beam, the aircrete insulation for the slab,
Mm-hmm.
the first dome structural shell that you build, and then you put a second airform over that, and you build a thinner, maybe just a 1/2 inch thick dome shell over that, with ideally 1 foot cavity in between the
Mm-hmm.
first dome shell and the second. And then you just fill that cavity with aircrete. And this is the easiest way to do it. All you need is a $60 stucco sprayer, a
Mm-hmm.
3 or 4 jet nozzle sprayer, and a compressor and a handheld mixer. With the simplest tools, you can make your airform, sew it up, inflate it with a leaf blower or a bouncy house blower. Bouncy house blower is preferable.
Oh, that's what's up.
I did use a leaf blower to build 3 domes. Just the leaf blower, inflated the whole airform, and all this is on my videos.
So it's only
Inflated
like
the
what,
whole
like 10
airform.
PSI or something, 20 PSI?
Yeah, it's very low
Right.
PSI, but when you think about it, your car tire has 30 PSI, and it's holding up, like a 2,000-pound vehicle. So that air pressure is very powerful. You can actually stand on the airform while it's just air pumping it in.
Wow.
So it's strong. So yeah, so that's
amazing. Yeah, I'd seen this
really
done years ago. I was at some expo in LA with actually my permaculture teacher, Larry Santoyo, was there. And I was there with a natural building friend of mine, this guy, Ray Serino. And they were doing a little demonstration of these concrete
your
domes, this
image
monolithic
froze if you
technique,
could see me
But they had
or if you can hear
5-Ek
me.
material there. And they
The
were
image
showing,
is
we could just sew
frozen.
the 5-Ek in any shape you want. And they were pressurizing it and showing how it worked. And so that's how you're actually puffing that up, you're applying the first layer over the outside, right? And then when that sets up, you take the form out immediately. Is that right?
Yeah, once it all sets up, you can reuse the airforms if you purchase reusable airforms, like I
I see.
did.
I see.
But the Tyvek airform, because the cement sticks to it, when you peel the Tyvek airform away, you will see some of the writing and text on the cement. So you can only assume a thin layer of that Tyvek has been left. So it's not going to have the same strength. So
Mhm,
I
mhm.
don't recommend using them twice, because if you have a failure, then you've wasted a lot of money and time,
Right,
you know,
right.
with it. And again, well, not again, but for one roll of the Tyvek house wrap material, it's right now it's about $220 here in Colorado for one roll. And with one roll that's 9 feet tall, 150 feet long, you can make one 20-foot diameter dome. There's enough material to make one 20-foot diameter dome with a 4-foot stem wall on it. So all my domes are hemispherical, right? Half of a circle, but then I add a 4-foot stem wall to it. And by doing that, instead of my walls curving in early, and I have to be like 3 feet away from the wall before the curve hit my head, by adding that 4 feet, I could stand against the wall and the curvature is nowhere near me. The
Sure.
curvature starts at about 6 feet.
Sure, that makes sense.
And as you know, with biogeometry and when it comes to the energies of a home, a perfectly spherical or hemispherical dome is not what you want to build for the energies. You want to have, like I do, a stem wall, or you want to have a different shape, but you don't want to have a perfectly hemispherical shape
Right.
for the energies, for the feng
Yeah,
shui, you could
it's
say.
charge isolative. The same way the echo in a spherical space would all come back right to the middle. It's it doesn't share energy with the outside environment or anything outside of it. It's
Yeah.
so charge isolation is generally bad for health and your body's energy. Yeah.
Yeah, for all growth, even like your plants or animals, you wouldn't want that.
Oh yeah.
So
All living things. Yeah.
that's one reason why I have a stem wall, is to break that hemispherical shape by adding a stem wall. And yeah. But what I'm
So
looking to do in the future are all egg-shaped airforms. So my future domes are going to be egg shaped, So I might have a 20-foot diameter egg. So, because of the shape of it, it might be really tall, but this is going to be the best when it comes to energies and for an environment to live in that's highly energetic and beneficial for all living organisms.
yeah, I agree. I think the egg shape, the quaternary or parabolic, they're all very similar curves, and it's already proven. I mean, it's not only the most structural, it's actually the reverse shape of the gravitational force. But it's also the most life-giving. I mean, otherwise, why would eggs be shaped that way, right?
Yeah, all eggs, snake
Right.
eggs,
There's
eggs, chicken
life.
eggs.
Yeah. And
Yeah,
if you take like a chicken egg, apparently there's a little bit of a voltage like from the bottom and the top. So it's showing how the egg shape, the complete egg, is actually a capacitor of some kind. It actually holds charge.
yeah,
So that's what we're trying to do with our homes, right? And I think it makes sense. Also, I was talking with some folks yesterday in a little consultation. We were talking about building a temple in New York, actually. And we are talking about making that egg-shaped dome above ground and then making that lower part, actually building that below ground or having some kind of a wooden floor that establishes like, at the spring line basically, and having a
yeah,
section that's below ground to complete the egg form.
right.
So
Yeah, I
yeah,
love
that's
it. That sounds
interesting.
great.
Yeah.
Yeah,
Reminds me of those water tanks you've been talking about building.
yeah, absolutely. If you guys go to my YouTube channel, you can probably search egg on my site, and you can see I have a 8-foot diameter, 11-foot tall airform made in the shape of an egg. And the purpose of that was to make water tanks. Now, the idea is it's based on Victor Schauberger's research with the energies of water flowing through these types of geometry. And I was actually inspired years later after learning about Victor Schauberger through Alosha's Bioveda course. He was talking a lot about eggs. So that inspired me to have an egg-shaped airform made. And the idea behind it is twofold. The first is you could take a flat level ground, dig a trench in that in the ground that's larger than the egg airform, and you could put that in the ground, tip down, and then you would, with weights or whatever to hold it down because it's going to be buoyant, you'd fill around that with cement. So that could be an aircrete, a dense aircrete mix, or just a regular concrete mix. But if you're using the dense aircrete mix, the other part of this is once that cures, you deflate the airform, pull it out, and you have a perfect shaped egg tank that's good for about 4,000 gallons of water. Now, the final technique would be to coat the inside of that tank that's made from aircrete with a magnesium-based cement, a reinforced magnesium-based cement. So that's going to give you a lot more strength because magnesium cement cures to like 10,000 PSI, whereas regular Portland cures to 4,000 to 5,000. And you're going to have your water in contact with magnesium, which is extremely beneficial to the human body. Magnesium's responsible for something like 250 other things in the body that depend on magnesium. So you'll be getting your magnesium into your water because we're all magnesium deficient.
Right. Yeah, that's brilliant. Yeah, one of the main things we always bring up about Portland cement is it actually has a lot of toxic heavy metals in it. So you don't want to build, right next to your garden bed or, in an area where there's high traffic, people are constantly touching it. The dust is very toxic in multiple ways, silicosis and heavy metals. So the magnesium cement, which is something that I've played around with, it's a great option. It's a bit more expensive, but it's so strong. You need such a thin layer to accomplish the same tasks. It's really designed to do a skim coat. And oftentimes, like we'll mix the magnesium cement with, put it into a mesh or otherwise like a fiberglass fibers mixed into the plaster. And magnesium cement, I think, is the wave of the future. And
Yeah, absolutely.
yeah,
The thing is with magnesium cement is you have to know how to mix it correctly so that it becomes waterproof. Uh, Straight magnesium oxide will not make a strong waterproof cement. So there's certain ratios you have to mix with the sand and maybe with some fly ash to make it really strong and really waterproof.
yeah,
So as you mentioned, it's perfect for a skim coat. When I was researching homes and what type of home I was going to build, there's a company in Nevada called Gigapanel. And Gigapanel builds similarly to Green Rhino Building Systems, what I described earlier. So what they do is they custom make their own studs, steel studs. So they custom make their own steel studs, and then they take big styrofoam boards, and with their CNC machines, they cut out the channels for the studs. And so basically, it's a really fast building system where they mount all the studs, then they slip the styrofoam panels over the studs, and then they put a fiberglass mesh and a skim coat of magnesium cement. So I mentioned this company because they sell their cement already pre-mixed. They have a proprietary blend where their mix has already been proven to have a fire rating of like 5 or 6 hours. They got past the regular like 15-minute fire rating and they pushed it like unbelievable. So their mix is waterproof, it has a high fire rating. Depending on how thick you use their magnesium-based cement, you can make your walls bulletproof. They show how 1 inch of their cement, layered in their technique, will stop a 50 BMG round. So that's a very powerful bullet. If you guys are not familiar with that, it's the largest rifle the U.S. military has for its troops, and they were able to stop that bullet round with a ceramic-based cement.
Yeah.
That was mind blowing.
Impressive. Yeah, that's mind
But
blowing.
you could contact this company, and as Scott says, it is expensive. It's like maybe $60 for a 60-pound bag of the cement, but it's going on thin. And this is what I recommend to everybody concerned about Portland cement. I say build your cement dome because of the cost, and then just cover everything with a thin coat of magnesium-based cement. That's going to stop anything bad leaching from the Portland, and it's going to stop all the bad negative energies coming from the earth and from the cosmic universe, because we're bombarded with these frequencies and all different radiations. And magnesium cement is proven to be a barrier against all the negative energies from the earth and from the cosmos.
Right.
So by doing a very thin coating all over the dome and your floors, you now negated the negative of the Portland cement. And because this magnesium cement sticks to everything, and it cures really quick. So you got to know how to apply it, because it cures so fast, but it sticks to everything. So you're guaranteed it's going to stick to whatever you put this cement onto.
Definitely. Yeah, the stuff cures so fast, you got to mix it up in very small batches. The stuff that I bought, it was like, maybe it was $100 for a 5-gallon bucket. It sounds like a lot, but I mean, you put it on at it between an eighth of an inch and a quarter of an inch thick. Generally, it doesn't need its own. It doesn't need a mesh. It has its own fibers already mixed in, and it's already mixed with an amount of sand that it will work as is. You can add more sand if you are okay with it being a little bit weaker, and it still is really strong when I added quite a bit more sand to it. So you could stretch it out. But I think the company I originally bought it from went out of business. It was out of Idaho. But anyway, this stuff is amazing. We managed to figure out you can also mix it up in a slurry and dip like a burlap cloth in there. And then whatever you lay the burlap cloth over, whatever form it takes, once it sets up, I mean, it's like it turns into like wood. It's hard. It's incredibly hard.
Yeah.
So
cool.
there's a lot of possibilities. We can play with magnesium cement and learn a lot more. And just brilliant that it's so non-toxic, and like you said, it blocks those telluric energies. The geopathic stress is nullified by some of these materials, and I think geopathic stress is generally nullified by any of your extra thick earthen walls as well, just because of the like piezoelectric qualities of the sand. Like a basalt sand is like a crystalline sand in there. So you get that from multiple materials, but from such a thin layer of that magnesium cement, all these different things we get, blocking the bullets, blocking telluric energies, it's pretty handy, and something we need to experiment with more for sure.
Yeah, I wish it were equivalent to Portland cement in price, because I wouldn't even use Portland cement. I would just use magnesium cement.
Oh, of course.
Because of course,
Yeah.
like I said,
it's just the manufacturing and the demand, it's just.
Yeah. And like you said, actually, you can mix it to a very liquidy form where you could get like one of those Graco sprayers, stucco sprayers, and spray it on just to apply it really quickly. And yeah.
Yeah, or possibly even like a cement paint. I don't know if you're familiar, but like with Portland cement, you can mix up a Portland cement like a thickness of like a buttermilk or something, like real thick.
Yeah.
And you can paint it on with a paintbrush, and it'll like seal in the pores, and it goes on very thin, and that's a way to kind of reinforce like the exterior surface of a shell. So I'm sure we could do the same thing with the magnesium cement.
Yeah, absolutely.
Yeah,
Absolutely.
got to
And I
mix it
like
up in
the
small
idea of
batches.
using I like the idea of using the reinforcement, just because, with all the experiments that I've done with cement, it's best when it's on some type of uh, structure like a fiberglass mesh or stucco wire mesh or basalt mesh, any kind of mesh. But the fiberglass mesh is a little better only because you can buy the sticky sided one, and that'll be make it really easy to apply it on the inside of the surface, because you could just stick this fiberglass mesh onto the surface and then spray it, and then know you got a monolithic strong structure.
Yeah, yeah, that's good. Yeah, making things easy and quick, not such a bad idea. And we keep talking about this basalt stuff. I want the audience to be aware, basalt roving and basalt mesh. It's a non-metallic mesh. It's made of minerals from basalt, and it's a little more expensive than the metal versions, but also doesn't create some of the geopathic effects that we find with when we put a metal mesh inside of the building. Uh, it actually blocks the bioenergy field. So we're trying to get away from that too, realizing the principles of bioarchitecture into our latest designs as we learn and grow. So
Yeah.
basalt
So
mesh.
the mesh, the basalt is made the same way fiberglass insulation is made. So if you've never seen fiberglass insulation, they take glass, heat it to molten, and with an airstream, they blast this molten glass, and it makes all these stringy fibers. So they do the same thing with the basalt. You take the lava rock, melt it, hit it with a blast of air that makes all these stringy fibers, and then they take those fibers, put it in a form with a resin, and that's how they make the basalt. And so they have basalt rebars, they have basalt meshes, they have basalt fiber chop that you can mix into your cement. That's another thing that I do. I mix the basalt fiber chop into my mix before I spray it. And the other benefits are there's a few. One is with steel rebar, you have to have at least 2 inches of cement on either side of your rebar. So your rebar would be in the middle, and you need that cement there to help stop water from penetrating, getting to the rebar, rusting it, and then make
Exactly. Yeah.
your entire structure weak and fall apart. So now, if you're using a steel rebar, you need like a 4 inch slab, let's say. But with basalt, that goes all the way down to like 1 inch. You could build very thin shell structures now because you're not worrying about rusting, nor are you worried about any other chemicals, because the basalt is impervious to all types of chemicals, and it definitely won't rust. So now, if you're living along the coastlines and you have a ton of seawater around you, technically you can use seawater for your cement structure, because the only reason it's not used is because the metal rebar and metal reinforcings will rust. If you're using basalt, now you can use the seawater and get whatever benefits you may get from all the micro particles in the seawater mixed into your cement.
Yeah, definitely. Yeah, I always tell people you think cement is strong, but it's limited by the lifespan of the metal they use to reinforce it, because
Yep.
cement always cracks, right? It's not if it'll crack, it's when it'll crack. And then water always goes in the cracks. And then it's only a matter of time before it rusts out the rebar. So pretty much, 99% of the buildings that you see around here are limited by the lifespan of their foundation, or if they're using cement walls. I mean, they eventually water may get in at some location and rust out the structural reinforcement, and then it's not strong at all. I mean, it will collapse, and so that's limiting the lifespan of all the cement buildings by maybe up to 100 years or less. And so if we can avoid using this iron rebar steel, um, I think it can really increase the lifespan, and also putting more energy, more money into what type of cement mix we're using, making it as strong as possible. It's just going to increase the longevity of these buildings. We might as well invest in buildings that last more than 100 years, in my opinion.
I agree. I'm of the same opinion.
Yeah.
As far as like the basalt and things, as you mentioned, the basalt is going to be a little more in cost than the steel, but there's a balance when you're figuring all this out. As I mentioned, if steel rebar, you need 4 inches of concrete. Now you need less concrete for basalt rebar. You're balancing out your budget now. Because yes, you spent a little more on the rebar, basalt rebar, but now you don't need as much cement here in this end, and you still have about the same strength and everything. So there's definitely a balance when it comes to the cost, what you don't need on one end because you're using material on the other. And then the other thing when it comes to building is the shape of your structure. Anything flat walls, square, needs a lot of reinforcement. Flat floors, you need a ton of reinforcing, if you're using concrete. Now, if the geometry is like a dome or some hyperbolic paraboloid shape or canonary vault, now you're looking at structures that support themselves, because now we're talking about arch. An arch is the strongest shape you could build. This is why Rome built everything using arches. Everything's an arch. And so a dome is a 360 arch. That's all a dome is. So these shapes are under compression. And so compression is what concrete loves. Concrete doesn't like tensile. This is what you need rebar for. A flat floor will buckle and cave without tons of rebar in it. But if you make a catenary shaped floor, right, for support, and then you put an aircrete slab on top to even out the sides, on the sides. Now, again, depending on the shape and geometry and what you're building, you can get away from not using any metal, because there are tons of structures that have been around for thousands of years that have no metal in them, but it's the geometry and the shape of the structures that led to its strength and why they still stand.
That's right. Yeah, working in compression, and like what Antonio Gaudi did with his work, they call it funicular science. Everything's in compression. I mean, and that concept came out of the ancient builders. I mean, all of those from Persia going back to the Egyptians, the Nubians, the Nubian vault, So yeah, I think compression is the way the geometry and the egg shape egg shape being one of the strongest shapes possible. I mean, it's the minimum amount of material for the maximum strength. So we just got to work with that. And I wanted to ask you one other question, going back to your particular technique with the double wall dome that you mentioned. So so you get your first shell in there, and then you get the second shell. So do you pump the aircrete in, or do you shovel it into a little hole at the top? How do you get the aircrete in between those two layers?
Yeah, that's exactly it. I leave a hole at the very top that I put a hose through. And in my video that I show, I use a DIY aircrete pump, which is just a 55-gallon drum that I put a little funnel on. I pour my aircrete into this drum, close that, and then I put air pressure on it, very low, like 5 PSI, and that pushes the aircrete up the tube, up to the top of the dome and in. So yeah, I fill it from the inside. And once it's been filled all the way to the top, then I'll cut my opening for my doorway and window, because the shells are thin. The outside shell is, like I said, maybe a ½ inch thick. The inside shell is maybe 1 inch to 2 inches. Usually thicker at the base and tapers up to the top. So it might be 1 inch at the top and 2 inches at the base. So, and the aircrete is very easy to cut through. So with a ceramic blade on an angle grinder, I just cut my opening, and then you have your opening, and again, you have something you could build really inexpensively. And I always tell people, if you're interested, build a small dome. That's how I started, an 8-foot dome. You could build a dome. It could be a shed. It could be a safe house. You know, if you live in wooded area, God forbid there's ever a fire, you have something that won't burn. The only thing you have to think of, if that's the reasoning for building it, is an air filtration system to block all the smoke from coming in. But otherwise, you can have a fire shelter, tornado shelter, earthquake shelter. You know, you could be living in a city right now, build a small dome in the backyard if you're in California or someplace where there's a lot of earthquake, and have someplace that you could go to that will be safe. Because that's the beauty of the domes. They are safe, tornado proof because of the geometry, earthquake proof because of the geometry, fireproof because of the materials, termite proof. They're virtually indestructible if built correctly.
Brilliant. A lot of people need that these days.
I
And
agree.
bulletproof.
Yeah, and bulletproof if you have enough cement on there.
That's great. Well, yeah, you know, I think we got a lot to look forward to in our conversations here, and we can do this again sometime. And I think there's, you know, a lot more experiments we need to do to integrate some of these natural building techniques with some of the techniques you're working on out there at your place. And I'm excited to try some of these things out and maybe combine, you know, earth bag or rammed earth with magnesium cement shell or some of these different combinations. There's a lot of possibilities there. So
I love the idea of the earth for its thermal mass. You know, obviously it's not great for very cold climates, but I love the thermal mass. So what you just said, you could build a very thin shell magnesium base dome over an airform, and then because of that strength, you could pack a ton of dirt on there. You could pack it. It could be wet dirt, so it packs really good. You know, just moist, not super wet, and you could just make a giant mound of soil. Again, I love the idea of using earth. Only reason I don't do it on my property is because I have so much clay and I really need a heavy piece of equipment to dig it. So I'm like, this is for me not worth it. But if I get another property like in Arizona or New Mexico or something like that, in the soils, those types, you know, good conditions, I'm all for it.
yeah, or you know, we can at some point maybe we'll invest and team up and get some other machinery and get some other team members as well. Like you got Lisa from Colorado Earth out there. She's got a whole factory where they make compressed earth blocks, and we may be able to get some blocks from her and play around with those, and also integrating the Catalan vault technique that we're studying. You know, when I just went to Spain to learn and bring that in, we get some fired tiles and create very thin shell roofs. I think there's a lot of potential there, and again, there's no metal in that system either. It works under compression and
And
uses an
no
appropriate
forms
amount of
either.
cement.
And
What's that?
no forms either with that method.
Right, no forms. Forms are optional. We use
Yeah.
strings to guide the tile work.
That's a beautiful system, and it's something I'm looking forward to building my own little pizza oven. It's going to be my first project where I use the tiles and just go nuts with my little 4-foot diameter pizza oven I want to make.
Yeah, exactly. And you can make your own tiles if you get some material that you think will work. It's the right thickness. You can use a saw to like cut your own rectangular bricks, and you can make a little miniature Catalan vault for your pizza oven.
Yeah. I mean, bottom line is for people looking to maybe either move out of the city and do what we're doing, going off grid. There are a lot of options that you have for building and for cost. And really, what we're working with are probably the least expensive ways you're going to be able to build a nice, safe structure that you could feel good in and safe. Because for me, home should be your safest place. Like if there's any natural catastrophe happening in the world, you want to know that you can go home and be safe, not have to leave home and run for your lives, you know, like in some of these movies, you know,
Right.
like War of the World. Everyone's leaving their house. Where are they running to? The woods. I'm like, no, I'm staying home. It's concrete. Protects me from alien invasions.
Right. Yeah. You got your water tanks and your food production. And
Yeah.
I remember you had one really good idea the other day. You were talking about building a greenhouse dome with a bunch of windows on the south side. It wasn't continuous glazing. It was like individual little bubble windows all over the place. And then you're going to run some mylar along the back. And I thought that was a brilliant idea because, you know, mylar is super reflective. I mean, you know, it's more reflective than mirrors.
Yeah.
It's like 99% reflective. And then, you know, you save a little bit on just the insulation. If you have less glazing over the face of your south face of your greenhouse or whatever kind of building you're trying to catch solar gain with, you're going to save money and insulative, you know, heat leaving through the windows. Basically, you're going to have less
Yeah.
window area and then increase the use of the light that actually enters the building. I thought that was a great idea.
And
And
then
then,
again, the main idea behind it was to maintain the structure. So because I'm building a dome, and then I have all these circular cutouts with little bubble dome skylights, all those circular cutouts are reinforced. So I maintain the strength of the dome, although there's a bunch of cutouts on the south facing side. Um, yeah, so that is I agree. That's a good idea. Who came up with that idea?
and they got those new materials now, like the ETFE, you know, the
Oh yeah, the plastic.
fluoropolymer
Yeah.
glazing. It's like a flexible, clear plastic kind of material, but it lasts forever. I mean, it lasts like hundreds of years because the molecules that it's made up of, for some reason, the UV light like doesn't even hit them or it bounces off. So like most things are broken down by UV light, right? We know this. You put a plastic toy out in the yard for a few years and UV light breaks it down. Most roofing materials are broken down by the light. So this is a type of glazing that's actually uh, much clearer. It lets through a lot more light than even windows.
Yeah, and
So
glass.
windows let through like 90 some percent, 92% or something like that. And this fluoropolymer material lets through like 98 or 99% of the light. So it's a new era for greenhouses, honestly, just because of that one new material. And it's super expensive stuff, but you only got to buy it once. I mean, it'll outlive you for sure.
Yeah, and it can be patched up easily if there's ever any holes that are made. For anyone wanting to see the world's largest greenhouse made of this material, go to YouTube and type in Eden Project. It's
Yeah.
in London, in England. London. I one of those two. And they have a large dome, a geodesic dome greenhouse that they built where they have tropical rainforest and really cool. But
Oh
that
yeah.
meant now I was told by someone, it still wasn't registering to me, but someone told me that material was made from man-made rubies. They took man-made rubies to make this ETFE material. And so I don't know how true or not true that is. I only heard it from one person. I thought it was very interesting, but it kind of made sense as to why this material is so strong. You know, you could literally put a car on this and it wouldn't even sag. It's just such a strong. It looks like plastic, but it's not plastic. It is way stronger than plastic.
Right. It's amazing stuff. Well, there's a lot of fun possibilities ahead of us. So we just got to keep our list of compelling experiments we want to do and just keep coming back to it. So
Sounds
thanks
good.
you for your dedication and your brilliance. Appreciate you, man.
Thank you, Scott. Appreciate you too, brother.